Welcome to the second part of Lesson 1.5 notes. We're going to do two more examples, and this time they're going to be with tables instead of graphs. So example 2a. In 2000, the CDC found the mean height h in centimeters for girls in the U.S. at various ages a, where h equals f of a. Some of these data are given in this table. You can see the table over on the right. Here's the table. If you look at, you have A values, 2, 4, 6, 8, and 10, and H values of 85, 101, 115, 127, and 138. The first question, part A, is what is the domain of the function defined by this table? Well, the domain is going to be all the A values, and I'll show you how you're going to write them. As you can see, I typed in the answer. You use a brace, and then all the domain values are going to be those top values for the A. So 2, 4, 6, 8, and 10. So then the range would be those H values, 85, 101, 115, 127, and 138. And you can see how I wrote them with the brace and then listed all the numbers and then ended with the brace. Part C, it says find f of 6. What does this represent? So if we look at our chart, f of 6, so we're going to go in at the A value of 6, and we come out with a 115. And I'll show you how you're going to write that. And what that represents is at age 6, because those A's stand for ages, girls in the U.S. have an average height of 115 centimeters. And that's how you would show it. F of 6 equals 115. And then finally part D, for what value of A does f of A equals 138? So now they want to know the value for A when they have f of A equals 138. So if we look at our chart, then that would be our height, that would be our h, because that equals f of a, and 138. Our a value is going to be 10. And you can see I wrote that in there. F of a equals 138 when a equals 10. So that means at 138 centimeters, the age would be 10. Okay, example 2b. Robert Wadlow is the tallest person in medical history whose height has been substantiated. At birth, he was of normal height. The table on the right gives his height h at various ages a, where h equals f of a. So here are his ages. So at 8, when he was 8 years old, 10 years old, 16, 18, and 22. And then you have his height at those different ages. So at 8 years old, he was 1.9 meters, not feet. That'd be pretty short. At 10 years old, he was 2 meters. At 16 years old, he was 2.4 meters tall. At 18 years old, he was 2.5 meters tall. And at 22 years old, he was 2.7 meters tall. See if you can figure out the conversion to feet to see how tall he would really be when he was 22. Okay, part A. What is the domain of the function defined by this table? Well, the domain is the independent variable. In this case, it's the age in years. So it's going to be 8, 10, 16, 18, and 22. You can see I wrote it there with the braces, so a brace, and then 8, 10, 16, 18, and 22, and then a closed brace. Those are all the values for age up here on the table. The next question, what is the range of the function defined by this table? Well, the range is going to be the dependent variable, which is height, because height that depends on the age. So in this case, the range would be 1.9, 2.0, 2.4, 2.5, and 2.7. Okay, you can see I wrote it in there. Be careful with the commas. Those are spaces, or those are individual numbers in between the commas. Part C, find f of 16. What does this represent? Well, f of 16 would be the age. So at age 16, how tall was Robert Wadlow? So at age 16, he was 2.4 meters tall. So you can see I wrote f of 16 equals 2.4. Just like I said, at his age 16, his height was 2.4 meters. Part D, for what value of a does f of a equal 2.7? So they want to know at the height 2.7 meters, and you can see I'm putting a square around it and an arrow at it. What age was Robert? Well, if you look up, he was 22. At 2.7 meters, he was 22 years old, or at 22 years old, he was 2.7 meters. You can see I wrote f of a equals 2.7 when a equals 22. So at age a equals 22 years old, his height was 2.7 meters.